All right. First, I would like to say Happy New Year, everyone. My name is Eric, and I'm one of the organizers of this meetup. My other co-organizers are Alison and
Hi, everyone.
Daniel and Justin, who's not able to join us today. He's traveling. Applied AI is a community where AI practitioners, enthusiasts, and knowledge seekers come together to learn, to teach, and to share with each other their expertise and perspectives on designing and implementing AI. If this is the first time you've joined us, I would like to extend a very warm welcome to you. If you've joined us in the past, thank you and welcome again. For those of you who are new, we always meet on the first Thursday of every month. Justin, who I mentioned as one of the organizers of this meetup, hosts a podcast called Conversations on Applied AI. Please give it a listen if you have a chance. I will share a link in the chat. Also, Justin is looking for guests, so if you're up to it, please reach out to him. We're also soliciting feedback on topics, activities, and events to do in 2022. I will share a link for a form for you to share feedback. This is your chance to shape what we do this year and put stuff out that's of interest to you. All right, so let me go on to our presenter this evening. Our presenter is John Henderson. John is a very good friend of mine. We happen to work for the same company, although in different divisions. But a couple years back, I want to say 6, 7, 8 years back, we worked for the same business. And ever since I have known John, he's always had creative projects going. I mean, he's too modest, but he's one of the most creative people I know. And we're talking juggling multiple projects, very desperate. So for example, I know, he's been programming robots to apply tape and to quantify the force that you need to peel the tape. He's also machining chess sets and board games out of exotic woods. And one of an interesting project that he worked on in the past, just like a fun project outside his day job, is analyzing data sets to understand the traits of properties, real estate properties that rent quickly and profitably. So he's just, as a mechanical engineer, he's got very just interesting pursuits, and I find that fascinating. John has been analyzing and visualizing data using R as long as he's been a mechanical engineer. I want to say over 10 years using R. And this evening, John is going to walk us through 2 interesting topics. The first one is an analysis of Reddit upvotes to answer amongst other things, whether the punctuality of a comment influences its popularity. So if somebody posts something and the first few people comment, is that comment more apt to be popular as opposed to comments a couple hours later? Then John will also walk us through how to interpret data and how to go about evaluating and examining the validity of the arguments that have been put forth in a theory. Let's say, for example, a conspiracy, like a major voter fraud conspiracy. How do you go about evaluating and just examining the validity of the arguments in that case? And even though the case has been presented very convincingly. So John, I want to say welcome and thank you for sharing your time with us this evening. Go ahead.
Participant now. It says I can't share my screen at the moment.
All right, let's see. Okay, there we go.
Oh, now co-host. All right. This one. Okay. Can you see that?
Mm-hmm.
Okay. Yeah, thanks so much for having me. Flattering welcome. I was a little intimidated, I admit it, because I haven't done really any AI. So hopefully something here, Eric assured me there'd be something relevant and already with the R question and just, what IDE or environment I use, hopefully there'll be something of interest to folks. Just to piggyback on what Eric said, first off, I would say it's awesome to be back at a meetup. I started learning R heavily via meetups, and I was at one point a co-organizer for the Twin Cities R user group, which I mainly joined because I just wanted to learn R, and I thought it's so much easier to learn from people versus online. And then I was completely blown away that that there was an R meetup group in the Twin Cities. And it hadn't met in a while. And so I had pinged the message board and said, is this a dead meetup? And that kind of resurrected it of sorts. And I think it's still going quite well. The main issue is that I have a lot more kids than I had back when I was doing all this stuff. So it's just been a while. I can't quite see the face panel. Hold on. I told Eric too, I've been working off this sewing machine table from home for too long, and I finally got a desk. Like this, literally, I just got this desk like earlier this afternoon off of Craigslist. So I'm trying to manage my new setup here. But yeah, I started with R just because I liked it. Dovetailing on the question, I think it was Bruce. I can't see your face right now, but I was using this program called Emacs org mode, and you can embed source code blocks in it. And one of the ones that works well is R, and I'd heard a lot about it for data science. So I just dug in and got involved in the Twin Cities R user group and use it as part of my job. I work in product development at 3M. I originally started in a corporate research laboratory working on something called non-wovens, which I always explain to people as melting down plastic and spraying it out of little holes like cotton candy. So that's how we make respirators, Filtrete filters, medical tapes. You can also buy the fibers in like hay bales and comb them out. So that's how things like Scotch-Brite pads are made. So I started there, was there for 3 years, and then moved on to a division called Automotive Aftermarket, which is fancy for collision repair. And so I joined that group working on masking tape. Later joined our group that makes paint cups. So we have a line of plastic paint cups that go on the top of spray guns to hold the paint when they're refinishing cars. And then got the opportunity, one of the plugs, I don't know, other hobbyists here, but another plug for just kind of building a skill up from basically nothing as people started to see me coding, which again, I don't know, I'm torn on, am I modest or am I accurate? I don't think of myself as a pro or anything, but at a materials company like 3M, some of these digital things can seem like magic. And so, some managers saw that I liked to do things with like Arduino and microcontrollers and sensors, as well as programming. And I got the opportunity to go learn some robotics and try to apply that in my division for testing automation. And then more recently, I've kind of been just doing full-fledged data science. So it's been a cool ride, meandering path for sure. I debate whether it's like an advantage that I'm such a generalist or, if I should be an expert after 13 years of work experience. But anyway, we'll go from there. So I'll just get into it. I've just kind of cobbled together a bunch of stuff. I do like showing other things that I do just because you never know. But I do some woodworking, make cribbage boards. I did get a CNC router a bit back. And this is one of the cool projects I've done is just taking pictures as me and my brother and just reducing them down to just to 2 colors. You kind of have to know the picture to like it, but that's kind of the point is you give this to somebody who knows the picture that it's referred to, although I did start putting it in on the back just as a reference. But they've made for some cool gifts as me and my dad, one of my favorite pictures from high school. Did this one in aluminum for a anniversary gift for my wife. Somebody dresses their cat up in these ridiculous costumes and sent us a calendar of her cat in like 1 cat picture per month. And as a thank you gift, I did this for her and some more dog pictures. So some fun stuff there. I recently got into mechanical keyboards a little bit and wondered, because I'm cheap, I wondered how much I could make myself. So I made the wooden plate, bought the switches, and then made these cases. I made 2 of them. And then my masterpiece, which I don't know if I'll ever top, was making this entire chess set. So doing like double-sided machining, which was new for me. So being able to flip these pieces, I felt very clever, I'll say, with machining this post into the bottom, because I put that in my drill press so I could sand it later. You would never do this like this in the real world. Everybody uses a lathe, but once I saw that nobody was making chess sets on a CNC router, I had to try. So, all right, enough of that. So we'll dive in. This was the first, this is the first topic Eric mentioned, but I put this on Data is Beautiful. It didn't get like any traction at all, which is kind of funny, but you know, basically the gist was, every time I go to a Reddit post and, you know, you see that post at the top with like 2,000 upvotes, I started at one point looking, and the comment would say like 7 hours ago, and the post would say 7 hours ago. And then I started noticing this, like every top post is basically, by the time I got to it, you know, the granularity of the time is in hours, and they're always like synonymous with the time the post was made. So I just thought, like, how common is that? Like, basically, how dominant are the early comments on Reddit? So this list down at the bottom, I'll maybe work like bottom up first. Okay. So I found the top 50 subreddits, and I don't know how they define top 50, maybe most posts, most activity, I'm not sure. And then I added a few that I like. I used the Reddit API, which I'll show the code in a second if you've never used it or have a use for it, but use the Reddit API to get the top 150 posts from each subreddit. Then per post, I asked for the oldest 500 by setting the search to old and get the top 500 of those. And then I also then requeried the API to get the top 10 comments by score. So in, you know, all said and done, it was like 7,000 posts. Yeah, 3 million comments and about 7,000 posts from those 57 subs. And then I kind of poked around. I didn't know exactly how I would process all of this. You know, it's a mess of data. I collected some other auxiliary data, which I can show in the code, but basically what I find is on the right, that's the top 10 comments per post. And what I did is I took the score and divided it by the mean of the top 10 and the oldest 500. So I called that the score dominance, basically. And what I found was interesting is, like, after you get done with the top 10 posts, basically the tail is extremely long and it's an extremely steep drop, because once you remove those top 10, you know, this was the highest remaining one and the oldest 500 of any of those 3 million comments. And so, and over here, you know, you're hitting like 300 times the mean score easily. There's not actually a ton here. Eric had seen this and included there. You know, I have a hard time going super deep into this, and there's some nuances about the API that I didn't know at the time that I wish I had known, which maybe would have let me do this a little bit more thoroughly. Like looking at the hierarchy or nesting, that's something I didn't get to do. But I did make some notes. My main takeaway from this, when I was thinking about it, is, you know, think about our life on the internet in social media. And what this is basically telling me is, when you go to process, like, what are people thinking or saying, right? I like to read people's thoughts on things. You're basically being served up whoever got there first, which is probably a bad proxy for the most interesting or useful things to know about a topic. So it was mainly, I made this, that's why I put the title there, right? With great punctuality comes great responsibility. If you get there early, chances are you'll be highly rated and more people will see you and more people will click, yeah, that's cool, upvote. It already has 2,000, it must be a good comment, so I'll just give it one more vote. The other thought I had was, like, maybe we shouldn't have a default search of like best on Reddit. Maybe it would be better to be like random, just to see what other people are saying. There was a link, I won't go into it now. Somebody posted that somebody had done something similar, and maybe this is sort of a trivial finding, but I was just curious about it, wanted to do it. I had just taken a series of classes. I'm going to blank, of course, on the name at the moment when it matters, but a series of courses on Coursera. This is back in like I don't remember when I did this exactly, but I should know from the post. Anyway, it doesn't matter. But I had just taken a series of courses on like web querying with Python, so this was just a good way to kind of practice, I guess, if you will, and I had never used the Reddit API. I don't know if that's useful to anybody, but this is kind of the gist of what you do. The library is called praw. Set up probably things like you're used to with any sort of API, pass in some credentials. Here's where I fed it that list. And then I just had some different functions that would extract, you get back, I think it was a JSON object. Again, this was a while ago, but, extracting out the ID, the title, how many comments, the score when it was created. And then when it got to the data processing part, sorting by was it new or was it in the top 10 or was it old? And then just saving out this massive number of files and kind of, gut checking myself along the way. How many posts do I have and whatnot? What I was going to say is that I'd set a limit to, again, this is a nuance, but I'll just throw it out there. I'd set a limit somewhere of I wanted 1,000 old comments, and it has to do with how Reddit treats the more comments. If you go on I'll just skip this quick, but if you've ever scrolled Reddit, right, and you see continue this thread, they treat that sort of like an object where you have to expand the thread to be able to get everything. So because of that, there's some nuances about what level a post might be in, or how Reddit decides to fold that thread and give it back to you. So I don't know why I asked for 1,000, but only got 500. And also that messes with like the ability to see what level of comment this was. So what I don't know is like, were there some third level comments that maybe were hidden that were in the top 10, but I didn't know because I didn't get them, or how the sort works. So the API and the kind of interface, I feel like don't necessarily align. And I had a long, there's a Reddit, like praw Reddit, where I was asking some of the devs for coaching, and basically he was like, it's complicated, just take what you get back and don't worry about it. So otherwise your queries go up massively, and there's a limit of how many you can do because it has to send an extra API query to keep unfolding all those comments. But that was this was just more of like a weekend curiosity. I don't know if anybody has thoughts on there, but mainly my takeaway was like, it's interesting to think about how the internet is scroll burden. I don't know if that's a real term or if I made it up, but just like, what's your patience to like keep scrolling down the page and see what somebody has to say? And I think that this says like, it's pretty short. I'll scroll a few, I'll look at what it says, and then I'll move on with my life. So that was that project. This one was pretty cool. I have a presentation on this. I'll show in a second, but this was the 52 bridge.
John,
oh yeah.
Before you move to the next topic,
sure.
Any questions, comments?
Oh yeah, and you can feel free to interrupt at any time, I would say.
John, did you have any hypothesis when you started this work? Did you make the assumption that it was temporarily sorted, or did you think that there was some kind of AI shenanigans going on that were spamming certain posts?
Oh, that's a good question. I didn't know about that. I mean, I was gut checking my anecdotal observation that, the post and the top comments would often have the same, I'll just scroll down here, right? One year ago, 1 year ago. I mean, if you looked at a more recent post, right, it would be in the order of hours, but it was mainly seeing that the top comments kept aligning to the time of the post. But I didn't think about anything being like manipulated per se. I did do a little bit. I mean, we could maybe return to this a little bit. I had some other plots where I tried to look at like the density of the timing across different subreddits. Part of the challenge with that was that pulling 500 as a flat number probably wasn't a good idea because of the relative size differences of subreddits. So like what I would find is that the first 500 were within like, I don't know, maybe minutes for a subreddit like R funny or R pics, where there's just a ton of people, and you're also not really looking for like a ton of nuanced discussion there anyway, was my thinking. But I did pull in like debate religion was super interesting. It had a hugely long tail, and some of the top posts were actually like later in life. So I feel like maybe people are coming back to those. Our science was another one with a longer tail. So I think that there are some where, people are game to have, nuanced discussion and do that. But really, I should have probably done something like, what's the mean number of comments per post? And then like probably should have done a first query like that. And then I should have pulled some % of those rather than just doing a fixed 500, because it shortchanged a lot of the huge subreddits. But my main thing was just like, am I right that it's for, if you're first, you are gonna blow up here. So like karma hunters, karma farmers, as people call it. So you really got to be watching to snag the opportunity.
John, super interesting. And your thing about how the first comment, it's almost like a self-reinforcing thing where like that one gets upvoted just by nature of being first. It reminded me a little bit of like that thing when you go to a conference, to a poster session, and like the posters that have the most people at them, like inevitably end up getting even more people going to them because other people walk by and think that those are the interesting ones.
And, sure.
Maybe it's like you don't want to get stuck talking to the person where there's no one at their poster. I don't know. But anyway, it seems like kind of the same phenomenon in some ways.
Yeah, that's a great point. Yeah, people assume what everybody else already thought was good must be good,
Right.
All right. I guess I'm skipping to the punchline here, but so I drive the 52 bridge. Well, when we were, doing the thing called working at a place, I was driving the 52 bridge every day. And it was down for like January 2011 to maybe March of 2015. Oh, it's right there. It closed down, end of 2010, and it reopened first quarter, second quarter of 2016. So I get on the new bridge, and I just thought, this is a nightmare. I should just skip to. Let me just skip to this. This will be a better ride. Okay. We'll start here and we'll work up to the graphics. So I don't, this is funny, but my mechanical keyboard is a 60% keyboard, and I need I bet I can do it somehow. Let me not full screen that. I literally don't know how to do, I don't have an F11 on this keyboard. So anyway, we'll just leave it like this. So I take this bridge every day. It was replaced for $130 million. And this is the gist of why I think the main problem exists with the new bridge. The top is the old bridge. So you used to merge on the right, and that would leave. Oh, sorry, I have highlighted here. Sorry, I actually don't know what I'm highlighting there. But anyway, most people, what they want is 94 West. So when I get on the bridge in the morning at Plato Boulevard, that lane never actually merges. It just is the exit lane for West 7th. So that's the first problem. It's not a true merge. The middle lane goes left or west to 94 West, and the left lane goes right or east to 94 East. So when I merge on in the right lane, I have to cross it 2 times to get in the lane I want. The middle lane, which is always the most full in the morning, goes from 55 around a 30-mile-an-hour hairpin. So it's always a brick wall. And the big problem with it not being a true merge is no one knows what to do. Should you merge right away, or should you zipper merge, even though it's not really a merge? And if you merge right away, you're basically stopping at the top of an on-ramp to try to fight your way into a brick wall. And if you go down to the end, everybody thinks you're skipping, and they don't want to let you in, and it gets nuts. Plus, I don't even want the middle lane. I need to get over again. So you also have massive speed differences, because I'm going from a fast moving lane into nothing. And then I'm going from nothing, looking in my left mirror, trying to like gun it and not get rear-ended by somebody in the left lane who's unrestricted. Also, bad drivers exist. So I emailed MnDOT twice. I tried to be a good citizen. Hey, something seems wrong. Here's what I see. This doesn't seem right. Let's see, about 6 months later, I got a little bit more snarky. I hate to be a jerk, but have any of you traveled this stretch and seen how confusing it is? Like, am I crazy here? And then, I went on with life. I hated this part of my day. And then I started to notice like, well, wait, there's like glass and plastic in the shoulders. Maybe people are actually having more crashes. So then I went about trying to figure out, how would I find that out myself? So the St. Paul police had some crash reports, and they would post this link with a 1 week button. So 1 week of time, you could get this Excel spreadsheet. I observed that the file names looked systematic. So I wrote a little script to just cycle through the dates. They don't give you links to all the reports, but maybe they exist, right? So I just started guessing and wrote something to cycle through the weeks. And I did okay. And then it was pretty funny. I wondered if it was somebody's job to do this, because every once in a while they just wouldn't exist for a week or two, and it would be in the summer. And I wondered if that person went on vacation. It looks like an Excel from a PDF. So I very much imagined somebody's printing and uploading it. So I looked at the Department of Safety. I gave up on that. And it didn't go back far enough. And it was also going to be a mess. I don't recall if it even had latitude and longitude in there. But the Department of Safety has a ton of aggregate data on crashes. So I figured they must have data, and they also have really appealing titles like research analyst specialist, which sounds like somebody who works with data. So I sent a cold email, didn't hear back for a while, and thought there's no way they're going to give me the data. I sent a follow-up like a week or two later, and a very kind woman gave me a link to an FTP site and a login, and gave me this, and it is public data. It's not like I got access to secret data or anything, but she shared where to get this data. So I stayed up, pretty much all night like a giddy child to figure out like, okay, what's the answer? And it looked like preliminary results were crashes were up to almost three times on the new bridge. Then I followed up with MnDOT to say, hey, I'm that guy that thought the bridge wasn't so good, and now I have data that shows it. And they also inevitably acknowledge that they have increased, and I wouldn't say they listed some solutions. They were looking into signage. Anyway, it was just kind of like, yes, we gut checked you, and this appears to be true. So I posted this thing on Reddit. That's what I was showing here. And this was just the eye candy version, and what I was really going after was like, okay, if I create this pulse of like, what did the crash rate look like by day on the old bridge? A lot of people in the comments were like, big whoop, it's a GIF, it is data is beautiful. So I expect people to be critical, right? But the kind of takeaway some had was like, it's a GIF. I could learn just as much just from that little blurb. But I liked the visual aspect of like, once the blue stops, you see kind of like boom, boom, boom. So I did feel like it got that away. I went to bed that night, and this thing had like 500 or 1,000 upvotes, which I thought already was nuts. And then contrast that with this, by the way. Like, I don't know why Reddit finds some things interesting and others. This got 83 votes, and somehow this hit 14,000. People were cross-posting on a civil engineering forum, so I was getting a bunch of like good feedback. Some criticism, but feedback from people who knew how this stuff is measured. So it's pretty cool. I actually did this. I forget why I did it in both, but I kind of walk through here what to do. I don't know if I'll dive heavy into the code here, but I'll just kind of walk you through what I did. After I first got the data, and I needed to know, well, where is the bridge? I needed to filter to some latitude and longitude polygon, if you will, to know if a crash in the data was on the bridge or not. I did have a panic attack after I got my first 2.7 finding of wondering, oh my gosh, is the old bridge where the new bridge is? Or are some like over the water now? And it turns out the top and the bottom are exactly the same. So it was all good there. The new bridge is just a little wider. Put some pins to estimate where the bridge is. I added 10% buffer to that. And then we filter the data to, I wanted to know if it was before the bridge, and then also after the bridge. I omitted the section in there. I think there actually were some crashes reported during that range. I don't know how that makes sense because the bridge was closed, but just to eliminate noise, I eliminated those, or filtered those out. And then wrote this my little note to self of point slope formula to know how, given a certain latitude, is it in my range of longitude that I care about? And then I kept all of those. And then the rest is pretty straightforward. Just group by the before and after state and count up how many crashes there were and what the rate was. Just divide the crashes by the number of days in the period, and that was it. So that was pretty straightforward. I did some quarterly plots. I'll just skip to this one. But just to see by quarter, you know, they're higher for sure. I don't know if anybody works with Folium, but that's it's the Python library for leaflet maps, which is pretty cool. I don't have it here. I've played around with doing some interactive stuff, which I had a version 2 of this that I wanted to pursue, and it's just kind of been on the back burner. I may return to it at one point. But it gives you pretty maps, I guess I would say, and you can also zoom and get everything you would expect out of like a Google Maps. It's just provided by OpenStreetMap, and that's how I did my my points there was with Folium. And so for each plot, this is just a bunch of nuance about how you add things in HTML in a not pretty way to a Python code blob. And then for each point, I ended up doing like 4 steps. So, you know, you can see I generated frames with kind of the date they happened. They were a certain size. And then I created 4 frames each. So they faded into the final size, and then saved all of those out to a big directory, and then used a Linux command convert, which maybe comes from ImageMagick, perhaps, that package. And you can just convert those into a GIF. So for the next steps of what I was going to do and some of the things I got feedback on, super interesting. So don't count crashes as an absolute number, but count them as a portion of the annual average daily traffic, which I learned a new term. So it's like number of vehicles going past a sort of a waypoint, if you will. Think of it like your current, I guess. And it's normalized for, you know, take everybody that passes that roadway and figure out what the average per day is. So that was one point, is could the traffic just be higher on the new bridge period? And that's why they went up. I did look into that, might account for 7% or so. Somebody pointed out, you know, tons of people, smartphones didn't exist back then. Smartphones didn't exist back then. It's like, okay, all right. So the iPhone came out in 2007. Some sources say something like 25% of crashes are from distracted driving. So worst case, you assume that everybody between 2007 and 2010 didn't have a phone, and that everybody afterwards is getting in crashes. 1 out of 4 crashes is avoidable due to a phone. If you stripped those out, I think I was still at something like 1.9x. So it's still doubled essentially. Weather got brought up, which I didn't buy, because if there's bad weather on one roadway, there's bad weather on another roadway, but fair enough. What started to get interesting was that public crash data had data for all of Ramsey County. So what I started thinking about was, and I didn't do it, but what I had in my mind was divide up the map into a grid of pixels, if you will, and then treat your time vector as like a voxel, so a depth. So I have this little voxel for a roadway at a particular time. And how I thought of it in my head is I would be looking at this transparent cube, trying to find the voxels with the greatest delta, and how many of those were on the bridge, and were the ones on the bridge about the same as any of the other roadway changes, or so the color, or maybe the density, if you will, would be like the ratio between the old crash rate and the new crash rate. And so the ones that really pop would be the ones that had gone through a change in that time. I never did that, but it was cool. You know, and so I liked the project. It seems like a potential public good. Somebody at work forwarded me a note from their, I don't remember his title, like alderman, something like that, who had a write-up that they were looking into working on the bridge. And so I cold emailed him, and maybe it was a senator or a representative, you know, my work, and said, hey, if this can help you anyway, I'm all for it. So maybe some public good there, which not everything I do in data has any public good at all. It was definitely challenging enough to be interesting, right? Getting into that sense of flow. There was definitely a sense of like vengeance, and felt like a win for data science. And one of the responses from MnDOT was, you know, they looked at pavement markings, but the temperatures were too low. By the time I had sent them this, it was winter again. So I thought, well, even uncovered, you know, if 3M ever came up with better pavement markings, maybe that would help them. They do now have paint on the road that tells you what lane you're in, because some of, I think what they think the problem is is that people get in a lane and have this intuitive sense of like, the middle probably goes right and the left probably goes left, but it's not. And so if you tell people earlier that they're in the wrong lane, that in theory would help them merge. As crazy as it sounds, the best I can figure out, like what I think happened is that their budget limited at the terminal side, and they couldn't rearrange the outputs to those 3 outlets. And so they just had to roll with them. And that's why we had this lane mix up. But really, the best thing I think they could do is take that Plato entrance and make it merge and then open it back up as an exit lane. It sounds insane because why would you kill a lane that is just going to open up anyway, but it would create a true merge and remove the ambiguity. And I think it's really the ambiguity that messes everybody up. So yeah, that's that was that project. So yeah, any thoughts or questions on that, or like ideas?
Well, on 694 in Shoreview, we used to have you used to have to, if you wanted to continue on 694, you had to cross 2 lanes. And it always backed up just because of the required merges. And the distance you had, see 694, when you came in, you were going to end up on 35. Of like whatever lane you entered from 694, you were going to be on 35 if you stayed in that lane. If you wanted to stay in 694, you had to change lanes twice.
Okay.
To get across it, you had to go through a middle lane and get to the other side, and it always backed up because of that, the required merging, and because the middle lane ended up with a really high density of cars compared to the other lanes, because everyone's trying to get through it. And yeah, most people did the merge early on because boy, I ended up on the wrong road a couple times and I decided to wait. It always slowed down at the beginning too. It tended to pick up speed towards the end when most people, like I said, most people did the merge early on.
Interesting. Yeah, I for another wild idea I had, and I don't know if anybody works with like road data, but if you could parameterize, make descriptive variables about a road. One of the things I thought would just be awesome. Part of it was like, why am I doing that? Shouldn't somebody have known this would be coming? Like going 55 to 30 just seems like, of course, you already knew what the traffic was from 52 to 94 West. Everybody could have seen that coming. So the problem is that it actually backs up south of Plato. So everybody coming in on Plato is already hitting a wall. It's not like you go a little bit and then everything slows down. It was already a wall. So you're already kind of quarantined off. But one of the crazy thoughts I had was like, if somebody could make a database of all roads in the US so that I could query it and say, give me all 3-lane bridges, less than 2 miles with 1 lane reducing from 55 to 30, basically like how many other 52 bridges of sorts matching certain parameters exist in the entire US. You know, couldn't traffic engineers kind of have a rule book that says like, these are the no-nos, data-driven no-nos, not just like, oh, probably this won't go well, but let's do it anyway. You know, basically like a rule that says like, after mining data from the whole US, which I think exists, but probably quarantined, you know, that's the other thing. If nobody's worked with government data, good Lord, the, you know, the sophistication, ease of access, varies like crazy. You know, some city governments, if you ever go look around for stuff, have really awesome data portals and APIs. They name their variables sanely instead of, you can tell they're giving it to data people rather than give me an Excel file with like merged titles and like the header row isn't in the first row, things like that. If we could kind of consolidate all this data across the US, it seems like there's something to learn here, that this bridge could be an example for anyone contemplating doing another one. I don't know if I'm describing like what I want exactly, but just the way to know, show me all the copy, you know, all the cookie cutter quasi 52s that exist in the US would be pretty cool. Or if anybody was considering a redo, to be able to say, or let them be able to find out, oh, that bridge you're thinking about redoing, there was one just like that in Minnesota. Check it out and see if you can do any better. Maybe that gets into AI. I don't know. All right. Yeah, any other comments on that?
John, do you actually write this in both R and Python?
I did do, yeah, that's a good question. I didn't put it on here. I think that I did. This has been a little bit. What did I do in both? I thought that I did, and I thought that was the point, is like I originally presented this at a Python meetup. I definitely originally did it in Python, but I think for work, I was curious. I actually got in a discussion with, so I learned R first. This will be, maybe this will be trolling fodder here, but I learned R first, and I was in a discussion with a colleague at work when I had started learning Pandas. And I said, man, Pandas seems so verbose compared to, to be fair, tidyverse, which is maybe just like a very specific flavor of R, not base R. But for what it's worth, it's the best, I think it's the best data library that R has to offer. And to my knowledge, I think Pandas would be considered that for Python. So I think it's still fair to say it's apples to apples. And she basically told me, like, you're doing it wrong. And I was like, I don't know, but I never had an example. So part of, I do think that I did it both. Yes, I did it in Python first for the original project, and then for a work presentation for an R, an R user group, if you will, at work, I did it again, just to test my theory. And I don't know, there are some things like, let me find a good example here, like this sort of stuff, like reordering categories. I guess I had to do that here with factors and levels. One of the things that has bit me often in Python is like trying to add a new column back in and getting errors about the index. And I know when I was a little bit newer to it, I found myself doing like dot reset index, drop equals true, or whatever the magic number. Like a lot of times I'm in a rush, right? And I just want the error to go away. I don't necessarily have the time to understand it. But the fact that Pandas uses, I think the term would be like a keyed data frame with a true index, makes it a little bit different than how R rolls, which maybe is bad for R because maybe you can merge things out of order, for example. But yes, I did do it in both languages for the exercise. Yeah.
It sounds like you prefer R.
I do for data science. I don't for general programming. I really like Python for mostly everything else, but once I have the data, I do like R, yeah. Mainly for the pipe syntax. I think that's what it's called. The little like this guy, and that comes from Magritter. Can't remember what package actually provides it, but it's in the tidyverse, and it's like a pipe. So the ability to kind of string these things together. Although I do have a like a Medium post open about doing that with Python and like chaining, getting fancy with like dot notation to be able to string things along multiple lines. But it is pretty nice. I mean, because you can comment out, and then once you get into the ggplot, you're ending everything with plus. So if I don't want to do this, I can just comment that line and not have to monkey around with everything else. So yeah, I do like it. I feel like it's pretty readable and generally concise. Yeah. All right. I don't like that. Okay, let me close that. So I had a how to like do the transition here to the interesting topics here. So I don't know what everybody's backgrounds are. I tested this with Eric. I kind of sprung this on him because I forgot that I had this when I originally gave him a list of topics. And I was like, oh, I know one that would be cool. It's probably the one that I think, I guess I could say I'm like one of the most proud things that I've done recently, or I just felt like it was pretty cool. Mainly, we'll just say I have loved ones in my life who like to send me voter fraud theories and ask me my opinion, / maybe imply that they're true. And so I was like, okay, yeah, sure. Like, I'll take a look at those. And I'll have some comments about this. Again, we don't need to get into politics. And I feel like the stuff I'm going to say is relevant for either side of the aisle here. But, as they would send me things, I dig this stuff. I feel like it's like sleuthing. You get to feel like you're participating. I was doing the same thing with COVID, graphing cases early on like a dummy. Oh my gosh, I don't understand anything about like how diseases spread, epidemiology or anything, but I was thinking, oh, can I see any patterns here? I was looking at Google mobility data. If anybody followed along with that, Apple was doing the same thing, but they had some cool data sets on basically like tracking mobile phones and known locations and basically where are people spending their time. So you could see that time at home had boosted way up, time to work was really down, time at parks was up. It was very cool stuff. A lot of the stuff about like, and some of it was to test what people said as well. And I felt like some of that had some bias as well. There was a article on Vox that was talking about the difference between California and New York. And it was saying that California had done so much better because they locked down earlier. And I thought, okay, like what was the time delta? And it was like 3 days. You know, like there's just no way that locking down 3 days difference like explains this. So I feel like I can go either way. I just hear claims, and if they're reproducible and able to be validated by data that I can get at, it's kind of fun to poke around and just see what you can find. One of the biggest reasons that I think that the stay-at-home, the official state stay-at-home didn't matter, which was being used to criticize a lot of states that weren't issuing those orders, is that Google mobility data showed that everybody in every county, I could pull it up later, maybe I'll include it like later if you send out a follow-up or something, every county in the US was down. And it was like, I think it was more about where you worked and if they sent you home than what your state said. Anyway, tangent, but I just like looking at this stuff, and it's relevant. It's what we're all thinking about anyway, so why not? I won't spend any time on these, but this is just like a couple examples of like, you know, somebody was writing an analysis to look at the New York Times JSON data that was being put out on election night and what those counts were, and claiming that they had this algorithm that was finding a bunch of like switched and lost votes and stuff like that. I looked at their code and it was very hard to follow, but I just went and got the New York Times data myself, and I just wanted to know what it looked like. So, you know, I plotted every state, and there were some anomalies. So one of the things that was being pointed out was like these crazy dips with Florida, right? So there were this many votes, it dropped to 0. Can you see my mouse, by the way? Like, does that show up on the screen?
No.
Oh, you don't see my mouse.
Maybe you need to scroll down a little more because Florida's cut off on the bottom.
Oh, it is. Are you not seeing the same thing I see? Florida up at the top right. Second to the right on the top.
Yep,
No.
second to the right.
Okay, so that big dip, I didn't know couldn't see my mouse. That's good to know. So there are some states with some dips in it that looked weird. This is a better view. I just pulled 2 of them out, for example, and that was a sign of like some anomaly. I mean, the first and foremost response is that the New York Times data source is not the official election results. But you know, it turns out if you just look through, you know, how the data was reported, it was by EIF data collected, which like didn't match the timestamps. And so if you omit the zeros, you get a sane graph. If you plot by the EIF data, you know, the sequence rather than the timestamps, which were out of order, you also got a sane graph. There was this other one, this guy is quite interesting. Oh man, this is recorded. Well, can I like be liable for anything? I looked at the work of this MIT scholar who touts his 4 degrees from MIT, and the main theory was that, I'm gonna skip some of the other stuff he said, but he looked at these counties in, I think it was Michigan, it's been a little while, but in a state with straight ticket voting. So straight ticket means you go in and you say, I just want all the Republican candidates. So you looked at that versus the people direct voting, and then what was the Republican margin among direct voters, and he took the difference of those. So like it amounts to the x-axis is your straight ticket vote, and the y-axis is like the direct vote Trump percent minus the straight ticket percent. In other words, he's plotting y minus x versus x. But he's saying this negative trend shouldn't exist. It should just be like scattered across the top, and we should see relatively similar percents. So again, nothing mind-blowing here, but just like if you work out, well, what are the maximums that my data can be, they will absolutely have a negative slope. And one of the things I'll say as my lead into the next theory I'll talk about is super frustrating. So like in science, all my stuff's on GitHub, the data's there, the code is there, there's nothing to hide, right? Reproduce it yourself. In every case I've looked at, this data is like magically obtained from I don't know who, it isn't shared, the code isn't shared. And so it's super brutal. So, again, though, it's kind of fun sleuthing. I ended up finding this report from a community college in Texas that had straight ticket versus direct ticket. It's just very hard to find data on straight ticket versus direct ticket voting. And the only point was to say that it's still a negative trend. And it's also a negative trend for Republican or Democrat, because of course it doesn't matter, right? And that's another thing that I would say as I've looked into these is I came up with this term called argument by inception. I will tell you that something is weird, like this negative slope shouldn't be there, but I don't defend why it shouldn't be there, or I don't give you any reference for what it should look like, nor are we shown the Democrat equivalent for this same county, right? Once you put both of them on there, it's like, oh, well, they both kind of drop, right? Like that's a lot of it's non-sensational. So I've started to coin some terms like, mathematical sleight of hand, argument by inception, like you're thinking it now only because I told you. So anyway, those are a couple of them. The main one turned out to be pretty interesting. So Dr. Frank, I can't remember his exact credentials, but among them, I'm pretty sure he had a cover page on Science magazine, something like a legit scientist. And his theory was included in this publication. I don't know what the word would be, a court case filed in Michigan by an attorney, Matthew DePerno, trying to get access to like voting machines and some other stuff and prove voter fraud in Michigan. It was the most in-depth, and I started doing my normal little like prototyping of code, and then I was like, okay, this is cool, and I got some data that I think was relevant, so I just kept running with it, and then I eventually switched to, I think it's still Bruce. I will show you like what I did this in, because that might be of interest to folks too, wrote basically a paper. So the gist goes like this. So there's bloated voter rolls in Michigan counties. So of the known 18 plus population, there's more registered voters than 18 plus population. Dr. Frank discovered a sixth order polynomial, what he calls a key, that can be fit such that the registered voters by age and the mean county turnout, and this polynomial key can predict the number of votes by age in the county. So what he's claiming is that this is evidence of a fraud mechanism, that phantom ballots are injected into this vote in proportion to this key, and it's programmed by state officials to make sure that the vote turns out the right way. And mainly these votes are injected on behalf of young voters because they're over-registered with respect to older voters and they don't turn up. So because we have these registrations who could have voted, but they don't actually show up, we're able to use this key to kind of inject fake votes on behalf of young voters who didn't actually show up. The TLDR is, this is the age, the population demographics version by age of this infographic, that all of these things correlate to the same thing. That's really all it is. And it'll make more sense, but if none of you have ever seen that, it's just basically like if you look up anything in the population, you're going to see where the cities are, where people live, right? So all these things work together and look the same because they all correlate back to a sort of parent variable, which is just who exists, okay? So I'm going to skip through some of this and we'll just walk through it in the graphic. This is what the key looks like. So this is what he's saying is programmed by the state. And dictates what the ultimate votes end up being. And then we start with Antrim County and he shows the registrations. Now this is like deceiving. So this is the key in blue, but now this is like a different plot, okay? So the blue is what the population curve looks like for Antrim County. The black is the registrations, which is higher than the population. Next, we're overlaying the votes and the predicted votes. So that's this red and this population register, yeah, predicted ballots over on the left. Sorry, I was getting confused with the key on the right. So the blue is his predicted ballots and the red is the real predicted votes, sorry, and the red is the real votes. So the main claim is that the fact that the red matches the shape so well with the blue, the prediction, that shouldn't be possible. And they match so well in shape that it's an algorithmically determined result. So that's what we have. So looking at the analysis, okay. And I read through this whole brief, right? So one of the claims made is the blue, black, and red lines on the graph are data. It's not speculative or calculated. It's 100% data. There is a little bit of cynicism in the paper, so work with me. From watching Sesame Street, I knew that one of these things was not like the other. The blue curve is supposed to be directly from the census population, but if you recall, these are jagged. It's kind of maybe what you'd expect if you just went by age and said what's going on here, but this population curve is smooth. So I doubt that it's a smooth transition between every age, right, and the data. So I basically just started by reproducing what he did from the ground up, and I thought, can I find, again, there was no data repository that he provided or anything like that, so I had to go look and see where can I find census data by age. To my knowledge, there is no census data by individual age, period. But anybody in the group, I'd be open to being corrected by that. All I could find was 5-year age ranges. And in particular, he says he used the 2019 census data, which are really from estimates predicted by applying models for like births, deaths, whatever else, to the 2010 data. So we're like 9 years out at this point of what they think. Also, this is at the county level. That might exist, but I just feel like, we're at a pretty small data set, so there's probably a lot of more noise going on at the county level than at the national level, but nonetheless. So I went and got that census data and then just, took their age range of who all exist in this 5-year range. You just plot a point, I'll use the mean for that range is my X point, and then the population divided by that 5 numbers of age for my estimate of how many people exist at that age. And then I did some, audible, I called an audible on the older population because it's like 85 plus. So you just have to pick something. So when we do that, also, has anybody heard of the tool Webplot Digitizer? We go here quick. I'll just show it to you because I think it's totally worth knowing. Sorry, I'm getting used to like where my workspaces are here. This is a sweet tool. Bless the man who, or woman, I think it is a man, yep, who made this tool, because you can upload an image and then apply tell it some things about like, is it boxes, is it points, is it lines? Apply some things like color filters, and then it is a little bit tedious, but you basically click around in there and say, here's the minimum point on my axis, and you tell it, oh, it's -2, and then click this positive one and say it's +2. And so you're basically just converting pixels into a data range. So if I said to find green, you can tell it what X spacing you want, and it'll spit out a CSV of XY coordinates for that green line. So I painstakingly fed his plots like these. So there's 9 of these counties. I fed it in there and did this 4 times, right, for each color to reproduce his data from his plots, since he didn't give me his data. So just wanted to point that out, but it's an awesome tool if you ever get like a picture of something and you want to get the data and then add to it or manipulate it. So with my, and this was, this was fun. I had a lot of like giddy school child moments here where, I did this, I didn't know if this would work out. And I'm like, oh my gosh, it matches, right? And then I thought, actually, it's just shifted by a little bit. So it looks like instead of using the mean for the range, like for 20 to 25-year-olds, instead of using 22.5, use 23. If you just shift over a little bit, I don't know what's the deal with this kind of like curvy thing here. Maybe he's just used another polynomial and it's flapping around because it doesn't know what to do down here, but near 100% match. So I felt really good about that. Yep, this is probably the population data that he used. Okay. To some of the claims, right? The registrations are more than the population. This is where the key theory is introduced, okay? So why is this key different in every state? Well, it depends on the demographics. So because the proportions of different ages who exist are different, we need a different polynomial to influence the vote. And then the main place where he says it is, so he's looking at the difference between the black curve, which was the registrations, and the red curve, which is the votes. And the observation, I should have just had a plot open. Sorry to keep scrolling back up here, but I'm just going to do it. This gap between black and red gets narrower the older you get, okay? So because of that, he's inferring that in these counties, the algorithm is overemphasizing young people. So the young people are least reliable. The algorithm tilts to the younger ages because they don't show up and they can provide the biggest credit line of votes that can be drawn on. So because those people didn't show up, but they're registered, we can use the algorithm to inject votes in whatever favor that we want. I didn't even get into the fact of like, well, there should be physical ballot, like, you know what I mean? Like, where do these ballots actually live? Are they just in a digital system? What happens when you hand recount? All that, just like, I'm just rolling with it at this point. So also, you know, to the shock value of if nobody's looked into like voting data before, just the fact that there's more registrations and voting than the voting population, you know, I'm pointing out there's a difference between saying there were more registered voters than voting age population. There were more votes than the voting age population. Those are worlds apart. And there's a whole bunch of links down here of like, you can find, this is a known problem. People move and they don't update. College students, you know, live somewhere for 4 years and register and then leave. Yes, states seem to have a voter roll problem, no question. But it also implicates plenty of previous elections. And to my knowledge, I've never seen anybody questioning them. Although when I've responded to some of these theories about like, well, wouldn't this have been a problem in 2016 or 2012 or the year before? It's like, yeah, they've all been controlled. So that I think is the way to maintain logical consistency, is just to, you know, there's been an invisible hand at work always. But if you don't play that trick, you know, you have to deal with the fact that there are inflated voter rolls in states that make no sense to have them, in states that have been like massively Republican or Democrat for like 20 years. It just makes no sense for them to do this, but yet they also have voter roll problems. Okay, so if we accept this and we look at what does this key actually do? So what he says the key is, if you want to check your theory, I'll get to that. If we want to check our theory, we graph the ratio between the black and the red. So we divide registrations by votes, and that creates the polynomial. The polynomial becomes the key. What isn't clear when he said that to me, when he said that, what wasn't clear to me is like, what came first? Did he find the polynomial and then check it? Or did he literally divide registrations by votes and that is the polynomial? I think it is the latter because I don't know how you would find it otherwise. But basically, just distilling that down, we're saying the number of registered voters times the county turnout times this key will tell you your predicted votes. Okay, now these additional points need to be true because the red is the real votes and some number of fake votes, right? He's saying his prediction and the red align. And so red is the real number of votes that occurred. And so if you have some number of fake votes in there, then the number of real votes must be less than the red, okay? So on election night, the real votes were lower than the red line, and the true count would be in the red minus these number of injected shadow ballots. And then put one more way, reality is something lower than red, and the algorithm shifts that away from reality and towards the black line, which is the fake reality of all these inflated registrations. However, you know, and I don't know if nobody in the courts read this, I don't know what the case turned out like, honestly, but if you just look at the key, we should just do it. Sorry, I'm going to go back up. If we look at the key, you know, I looked and I'm seeing, okay, it starts at like, let's say 1.1. And once we get into like age 20, we're already into less than 1 territory. And then from like 45 to almost 90, we're higher than 1, okay? So keep that in mind with respect to how this fraud theory supposedly works. I have some number of registered voters for like age 25, I multiply those by the turnout for Antrim County, which was 0.6-ish. And I'm further multiplying that times 0.8, the value of my key. And if I want to do the same thing for 75-year-olds, I have the same first values. What's the number of registered voters and what was the turnout? But then I'm now multiplying them by 1.2. So the key is synonymous with the algorithm, yet it actually adjusts younger voters downwards and it inflates older voters. So that's it does the opposite of what is said. On the note of turnout, you know, where is the 61.8% from Antrim? You can go on the Michigan State website and find that they say it was 72.6. And then I did a comparison of his, you know, the 9 counties that he looked at, and then what is the computed, and I did it both as a proportion of registered voters and as a proportion of the population. Technically turnout, you know, when they usually say like the US had 66.7% turnout for 2020, it's not the percentage of registered voters, but it's the percentage of the estimated voter eligible population. So voting age population is everyone over 18, voter eligible population is over 18 minus immigrants, folks who can't vote here, felons. I don't know what other categories there would be, but it's slightly smaller. But anyway, the point is, it's not usually percent of registered, but anyway, I calculated both values and they don't really match up to what he said. What I wondered about this is that he needed to kind of calculate this after the fact, because he has the polynomial at the statewide level, but that might not work out in a county. So he has a different turnout value for each county to basically make it work, to kind of shift where does that prediction end up. It needs to match the red line. So per county, you can compute a custom variable basically. Okay. So let me gain my bearing here. Oh, so the other thing I was wondering about with this is because of how turnout is usually discussed. Let me just do a time check. How are we on time, by the way? 7. Oh, we're like 10 minutes away. Is that still cool? I need to clip here, right?
We're good. We're good.
Okay.
Good.
Okay. So he could have used population for the input for the prediction, but he didn't. He used registrations. What I wondered about that is if you basically have a smooth curve population times this turnout, which is a fixed number, and then times the key, which is also smooth, you're going to get a smooth result. And I recreated this. And so this is what that would look like. If you just use population and then the green is me not using registrations, but using population as my input, you just get a smooth result. And so you lose all of that, the patterns match, you know, why was the spike in the prediction and in the votes? It shouldn't be like that. So that was one of my thoughts there. Also, yeah, we'll get to that too. So then I spent some time looking at claims around the correlation coefficient. We made the claim that, you know, it should never be higher than 0.8 unless human fiddling is involved. Or sorry, if humans are involved, like behavior, you'll never see higher than 0.8, and that indicates the algorithm is at play. I also looked at, you know, does this polynomial key? The claim was it works in every county in Michigan. But I just was curious because I had the census data, you know, I'm starting to wrap my mind at this point, and thanks for enduring with me because I'm basically like walking you through like how I thought about this problem. But I started thinking like, does it work everywhere? And I had all the census data. So what is he really doing? Well, he needs the statewide age demographics to kind of match the county demographics, or this thing doesn't work. The curve is going to be all wonky and you're going to get inflated or, you know, under-predicted or over-predicted votes. You know, I don't know how to say how similar these are, but you can see the 9 counties you looked at versus all of the counties. And I wondered again, if there's a little bit of sleight of hand with respect to which 9 counties were chosen, because you can look at the swing. So, you know, looking at all the counties in Michigan, and if you pick the under 30 population, here's the top 3 highest that are, you know, 40 to 50% under 30 and the lowest. So there's some very heavy swings in Michigan with respect to where people live. Went on to look further at this, you know, these claims of accuracy. We can predict the ballot demographics with remarkable precision. We have 99% certainty. Everybody thinks they're clean, except this algorithm also works with 99% certainty in this county. So the interesting thing here is, we have certainty without seeing the results. But if it hasn't like resonated in your brain by now, with the results in hand, he divided votes by registered population to get his polynomial, and then showed us that he could multiply the registered population by the polynomial to get the votes. I'm going to try to speed up a little bit here, but I just showed how trivial it is. Instead of multiplying by his key, I just multiplied by an even sequence from 4 to 8, the same length as the registered voters. So the green here is my prediction of votes. And if you run, Pearson's correlation coefficient, it's still 99%. So basically, like, it's more about, you all know this, I'm sure, but like, it's more about the shape of these things and do they move together, not are they accurate. Looked at a little bit of regression analysis. I think the percent one is more interesting. So even with this 99% correlation, you can be wrong by minus 15 to plus 25% error. Okay, so then I was curious, like, could I explain this illusion? It basically boils down to this. Like I said, it's like people live here, and so if you look at things that people do, you will see that heat map of the US, right? The XKCD cartoon at the beginning. The same thing is going on here. People of an age exist. Some of those people register, and some of those people vote. That's all it is. And then I offered some food for thought about how would that not be the case, right? If there was a spike of 73-year-olds in the population relative to 72 and 74-year-olds, how would that not show up in the registrations or the votes? I went and pulled, amazingly, the US Census Bureau has data by individual age, which I think is a key to making this work. You need the shapes to look, right? We're pattern seeking people. You need the shapes to work. So I didn't do any polynomial fitting here. I was just trying to show what does the voting age population, voting eligible population, the registrations and the votes look like for all the years back to I could get off the Census Bureau. And the shapes are strikingly similar. One of the coolest things, Eureka moments here, just like fun observations. Oh, you can't see my mouse, but if you look in the year 2000, there's a little blip. It's around age 53. This is such cool stuff. And like, I think the explanation makes so much sense because you can actually watch that peak walk its way every 2 years through the data. Why? I don't know what age that would be now, but in the year 2000, like, why were there so many 53-year-olds born versus 52 and 54? I don't know, but it just was like a baby boomer year or whatever. So it's pretty cool. So I felt really validated by that of, this is just an illusion. I looked at some cars, my analogy here was like, if we knew the distribution of cars and there's a lot more white cars bought than other colored cars. And then I looked at accident data and I said, wow, there's a ton of white cars in accidents. It wouldn't mean that there's an algorithm controlling who gets in accidents. And then the last, I probably won't dive into this, but I basically took my stab at a really sketchy data thing here, but I had that data by US county, the total US and by county populations for age group. We also have individual ages extracted from this age population pyramid that I found on Wikipedia. I don't know how they did it. It could be completely interpolated and nonsense. I don't know, but basically it was the only source of individual age data I could find for the US. And I tried my best to like really messily tell me what the Antrim County population should be by age. And then I did what he did. So like he's saying that this smoothed line, the point is that this smoothed line is what he says the population is. And in some counties, the vote actually did exceed that smooth line. So that would be a party foul of votes greater than the true population. But again, I just felt like, wow, this couldn't be going better for me, a hobby data person. Like the fact that my green model, which is like from a totally separate data set, modeled from 2010 census data, all the way to 2019 and then applied to this tiny little county, it has that peak. Like those people are real, they actually exist, and no longer does the red exceed the population. We just have really high turnout there at that age. So that was pretty cool. And then the last thing I did was show that you could predict. I just basically thought, like, how else could you look at this, right? And it's just harder to find geographic data. It's harder to find age demographic data than it is geographic. But I found some data on female smokers and drivers, and I showed that you could use a sixth order polynomial to predict the number of drivers based on the number of female smokers in the US. So that was what I did, and then I just kind of recapped with what the different claims were, and then kind of explained them. So I know that was a super whirlwind. That is on GitHub for anybody who wants to take a look. So the PDF is here, and I just updated that. So you'd be free to read it. And if people want to stay around, I mean, I know there's a lot there, but like I haven't shown this to a lot of people. Yeah, I'm just curious how it strikes you. But I'll end by saying, back to where I started, pitching this topic, this can be a little sensitive. One of the things I try to force myself to do, and I did have one more thing to show, and I promise it'll be relevant. I was looking at the Republican versus Democrat margin over the years. And this is a lead in here that, between 2012 and 2016, basically the lower you go, the higher the Republican margin, and the higher you go, the higher the Democrat margin. And these facets are by population, county population. The main thing I'm just pointing out is that we seem to be moving towards the extremes. The red is getting redder, the blue is getting bluer. I certainly went into this analysis thinking there is no fraud, and I think that surely sways, your initial prior estimates of things. However, I still think it's fair to say, like, I did my diligence and I put in my work to try to at least understand what he was saying. And I brought this plot up because I do think it's like a valid lesson of when we see things. Part of the worry that I have, and I'm sure you've seen it on social media too, is if someone says something, a new claim comes out, a new voter fraud theory, people who think they're fraud will say, I knew it, I told you, and circulate it around. And people who don't think there was fraud will say, there's no freaking way. And so part of like maybe where I'll leave you is, try to challenge that stuff, reproduce something that you don't believe in and just see. I try to take the approach. I'm not good at it, I promise, all the time, but like have nothing to fear from the truth. There's a great blog called Less Wrong. And it has a litany that I'll mess up here, but litany of Gendlin, which basically says, like, don't fear the truth because you're already living it. If there's voter fraud, there's nothing to be worried about because it already exists. Like, it's already a fact of reality, and we're just aligning our brains to discovering it. And so whatever that reality is, I hope to live by the motto that it's like, it's better to know it than to fight it. So anyway, that's my way of trying to tie things together and not make controversial topics scary. So yeah, that's all I got. Sorry to have like run up right to the schedule like that, but I guess I'm not surprised myself either. I'm kind of a blabbermouth.
No worries, John. So questions, comments? Like I said earlier, John is a man of very disparate creative pursuits. So woodworking, data analysis, theories, programming robots. It's so cool. So John and I meet often, monthly, at least once a month, and I really enjoy our conversations because I mean you're all over the place in a good way.
That's fair.
Yeah. Cool. Any questions, comments?
If Bruce is still on, also, this is my environment, by the way. Again, no real time left, but if Bruce is still on, this is called Emacs org mode.
Yeah.
Since nobody jumped in, I just wanted to show kind of how it works. It's similar to RStudio in that you can embed source code blocks, but I love the export to PDF, and you can kind of intersperse, like this is the paper you just saw. It's just in text format. I don't like writing LaTeX directly. So you get this kind of markup syntax. You get cool things like footnotes. So like if I go here, that takes me to that footnote.
Mhm.
And you can embed, didn't want to do that. That's what I want to do. Sorry. Stop that. I don't know why that won't go away, but I'll just leave it. And then if I got to like one of the plots, like you can run the code and then get the, I don't know where I have some code in here, but you can run the code and like get the results embedded in there. So like this generates that table. So again, I guess it'd be similar to like knitter or
Where is it?
anything like
Jupyter. It's a Jupyter kernel or something with Atom does that.
Yeah, I have a hard time, like, I do a lot of prototyping in Jupyter. I've never really used it to compile stuff. Maybe it would be easier. I feel like things get long. I probably could, yeah, fold stuff more. You know, this obviously has some nice like folding syntax. I'm sure Jupyter does have it. Maybe I'm just not as familiar with it, but part of it is like, I guess I got familiar with it. You can also do some interesting things. Probably one of the most used features is called the agenda mode. So I could like, do I still remember how to do it? Oh, I don't remember how. If I make this like a to do is like a known keyword. And then there's a way that if you're taking notes, you can extract just the to-dos from this whole thing. And that was the main reason I first found it, is like, as I was taking notes in like meetings or whatever, you always have all this stuff you want to know, but then you also have things that require action. And I found myself doing those in two separate places. And this thing was a way that merged it, so you could just do everything in one place. But I really, I don't know. I just think it's pretty. It feels cool to like make things that look clean and nice. You can decide if you want the code or the results exported. Yeah, it's probably again similar to tools that you know, but it's a big learning curve. But if you haven't, I took a lot of baby steps. That's basically how I did everything. Start super small, use it a day at a time, and it happened to stick.
Got it. Cool. Well, thanks.
Yeah. Well, feel free to reach out afterwards. I'm on the